Hello everyone and welcome back. In this lesson, we look at the sum of an arithmetic series. We will go through the process of summing an arithmetic series and look at problems related to summing arithmetic series. Remember, an arithmetic series is often called an arithmetic progression. Let's begin. Let's begin with that question that we had before where we start an exercise program and we run it for 2 weeks, starting by walking 20 minutes on the first day and adding 5 minutes every day after that. The time walked can be written in a sequence written such as AN is equal to 20, 25, 30, going up all the way to 85. And if we put plus signs between those numbers, then we end up with a series SN, starting at 20, going all the way up to 85. Now suppose we wanted to add these numbers to find out the total time walked. One way is simply to put this total in your calculator, one number at a time, and of course you get your result. In the event though that your sequence has a lot of numbers, so for example, suppose you decided to run your exercise program for 3 months, then that is a lot of numbers. And it would be a bit impractical to sit there and type 3 months of numbers into your calculator. So we want to find a more efficient and better way to add these kind of numbers in a sequence and series. So one nifty and tricky way, very smart way to do it is just to rewrite the sequence, this series of numbers here. And rather than have it in ascending order, we're going to write it in descending order. So we're going to have Sn again. And this time, instead of having it in ascending order, we write it in descending order. So 85 plus 80 plus, continuing all the way down to 20. And what we can do is add these two series together. So the series that is ascending and the series that is descending. Now notice that each of these will make a pair. So we have a pair here, we have a pair there, and we have a pair there. Each of them will make a pair with the other number that is descending. And what that will do is to create an easy way to actually sum the series. So if we add this series and this one together, then we have two of them. Remember, there are 14 terms, 1, 2, 3, 4, 14 terms. So the sum of the series, 14 terms, S14, we add these two, so we have two of them. We're going to add them together first. And when you add 80 and 25, you get 105. When you add 80 and 85 and 20, it's 105. And it happens all the way down until you reach here, it's still 105. Now there are 14 of these numbers, and we're adding them twice, so there are 14 pairs. And what happens is that we can take that 14, so 2 times the sum of the series is going to be 14 times 105, since there are 14 of these. And then now we can simply say, since we only want the sum of one of the series, to divide it by 2. And dividing that by 2 into 14 here gives us 7. And then our solution is simply 7 times 105, which is much easier to work out. And this here gives us 735. In this case, minutes. This kind of thinking where we take one series in ascending order and take the other one in descending order, add those two series together and get a result, that kind of thinking leads to this type of formula, where we have the sum of the first n terms of an arithmetic sequence, called the nth partial sum sometimes, or it is called a finite arithmetic series, is given by the formula Sn is equal to n divided by 2 times a1 plus an, where a1 is the first term and an is the last term. So if you're summing a series and you know the first term and you know the last term, you can simply go ahead and use this formula. And of course, if we know the number of terms but we don't know the last term, and we can find the first term and the common difference, we can use the formula in this way. Both formula are essentially the same. Let's try and use them. Back to the question again. So here we have this series to add. We know the number of terms. The number of terms is n equal 14. 14 terms because we exercised for 14 days. So using this version of the formula, Sn is equal to 14 over 2. We know the first term. The first term is 20. And we know the last term. The last term is 105. And we can simply use a formula like this and we get our result. So S14 would be equal to 7 times 105. And as we saw earlier, this is equal to 735. Using the other version of the formula, we know the number of terms. It's 14. So we can write our 14. We know the first term. The first term is 20. So we can say 2 times 20. Plus, we know what the common difference is, because when you look at this, we're adding 5 minutes each day. So the common difference is 5. And so it's 5 times 14 minus 1. That gives us 7 times 40 plus 5 times 13, which is 7 times 40 plus 65. And that again gives you 7 times 105, which gives you 735 minutes. So both formula are useful and each one has its own advantage. If we have the first term and last term and the number of terms, we can simply go ahead and use that, as in this case. And if we have the common difference and the number of terms along with the first term, we can use it in this form and get our answer as well. Let's look at this question here. New employees joining a firm in a clerical grade receive an annual salary of £8,500, let's just say dollars for now. Every year they stay with the firm, they get an increase of 800, up to a maximum of 13,100. How much does the new employee earn in total, up to and including the last year on maximum salary? So we know the first term. In the first year, the person will get 8,500, and on the last year, the person will get 13,300. What we do not know yet is the number of terms. So let's start by writing it out a little. In the first year, the person will get 8,500. In the second year, they will start getting the increase of 8,500 plus 1 times 800. And so we will have to do this. This is the second year. And so the person will have to stay 13 years. This is the first year. This is the second year. And in the second year, they got the increase. So if they stay with the firm for a maximum of 13 years, then this is what they get. So we're going to have 13 of these plus this one, which ends up being 14 terms. So the first term plus each of these all the way up to, and we end up with 14 terms. So we know the first term, we know the last term, and we know what the number of terms is. So we can use this one. So S14 again is going to be equal to 14 over 2 times the first term, which is 8,500, plus the last term, which is 8,500, plus 13 times 800. And that simplifies down to 7 times 2 times 2,500 8,500 plus 13 times 800. And when we multiply this out, what we end up getting is 191,800. Take a moment and plug that into your calculator and make sure that it works. So here, we mentioned that in the first year, this is the first year. In the second year, the person would get this. In the third year, they would get 8,500 plus 8,500 plus 1 times, not 1 this time, but 2 times 800. And so it will continue up until those 13 terms plus this first one. We end up being 14 terms. That's how we got 14 terms. 14 divided by 2 using this formula. And so we end up with the first term plus the last term, and we end up with our total. So up until that time, how much does the new employee earn in total, up to and including the year on maximum salary? The year on maximum salary would be the 14th year. All right. And then this would be the total that the person would have received. Let's look at another one. Simple one this time. Find the sum of 11 plus 14 plus 17 all the way up to 16 terms. Now we have the first term, but we do not have the last term. We have the number of terms. And because we have the number of terms, we can use this one. We can also find the common difference. The common difference would be 14 minus 11, which is 3. So using this version of the formula, S16, since there are 16 terms, would be 16 divided by 2 into the first term, 2 times the first term, so it's 2 times 11, plus the common difference, which is 3 times the number of terms, 16 minus 1. This gives us 8 times 22 plus 3 times 15, which is 8 times 22 plus 45, which turns out to be 8 times 67. And that works out to be 536. So by knowing the common difference, by knowing the number of terms, and by knowing the first term, we can use this version of the formula. And by simple substitution, we get our result. Let's try one more example. Here, the first term of an arithmetic series is 16, and the last term is 60. So we know the first term and the last term. The sum of the arithmetic series is 342. So find the common difference. So we know that Sn is equal to n over 2. Since we have that information, we're going to use this formula, times the first term plus the last term. Now let's substitute. So we have 342 is equal to number of terms we don't know, times the first term and the last term. So that's 16 plus 60. And that gives us 342 is equal to n divided by 2 into 76. Now, a half of 76, or 76 divided by 2 here, gives us 38. What we can write here is that 38, n, is equal to 342. And dividing by 38, we end up with the number of terms being 9. So there are 9 terms in this sequence. And we can use this formula to do other things. To find, for example, the first term, we can use it to find the common difference, and etc. Now, please remember to get more practice. The best way to remember these things and to get a deeper understanding of them is simply to practice more. And you can find more practice questions on our website or elsewhere. If you haven't subscribed as yet, please do so. Thanks for watching.